Welcome to this video. Rita Billy asked for this one, and this is Summer 19. Summer 19, question paper 41. This is question 8. Okay, the mass spectrum of X is that. Sorry, the mass spectrum of compound X is recorded, and that is X, C5H10O2. These are the heights of the M and the M plus 1. Excuse me. And we've got to show there are 5 carbon atoms. All right, let's do that. Number of carbon atoms is equal to the intensity of the M plus 1 peak divided by the intensity of the M peak times 100 divided by 1.1. That is 1.25 divided by 22.65 times 100 divided by 1.1, and that gives us 5.05. So there are 5 carbon atoms. Excuse me, there you go. Now, the mass spectrum of M has a peak of 57. This is, here we go, this is the molecular ion. So now we've got to find something that's 57. You need a calculator to do this, really, that's all you need. All right, but I'm going to go C, let me use a different color, CHO. Let me put numbers in. C2 is 24, a long way to go. Let's go C3, 36. 36 plus 16 is 42, 52. There you go. That's 57. All right. So I'm going to put my guess here as C3H5O, and it must be plus. If this is C3H5O, C5H10O2, the other one must be C2H5O. So this is C2H5O. There must be a plus here. Okay, because it's got to balance. Now, when we say equations balance, we mean they must balance in charge and a species. Okay, so there must be a plus here. All right, and this has a mass of 57. And I don't know what this is, but it doesn't ask for that, does it? But the peak will be due to the charged one. This will be a radical. The other one will be a radical. What's TMS? TMS is it's used for reference. It's tetramethylsilane, and it gives our reference peak at the delta value of 0 parts per million. It's our reference peak. CdCl3 is just a solvent. Okay, and it has deuterium in it, as you can see. And the reason we have deuterium here is so it does not mask our NMR. So we don't want things getting in the way. We don't want the solvent to get in the way of the peaks, do we? So we use a deuteriated solvent, CdCl3. All right, are we good? I think so. Let's move on. Let me pause this. Okay, this one shows a spectrum of C5H10O2. And there we get the spectrum. By considering both the relative peak areas and their delta values, use the data booklet to do these 3 things. Okay, we got to do these things. All right, and we're obviously going to have to find out the structure of the compound. Now, you can do this the way it suggests here using the data booklet, or the wrong way, and I'm going to do it the wrong way, okay, because I find this better. What I do is I look at the NMR. This is the NMR, and I make an educated guess, okay, and then I modify my guess to guess. I just spelled guess 2. Oh, guess 2, guess 1, and I modify it. Okay, and I try and fit this. And I often find this is the quicker way around. Let's see if I'm right this time. Right, you've got a peak at there. You have a quartet at 3.5, and you have a triplet at 1.2. If you ever have a quartet and a quartet and a triplet in the same place, it must mean you have a CH3. CH2 next to each other. It must do. That's the only thing it can be. Okay. Now we've got 2 isolated peaks, a 3 and a 2. Well, I'm going to assume that the CH3 is at the end of the molecule. That's this one. Okay. And it's isolated. So there's an O there. Okay. This one's also isolated. So I'm going to put an O there. And I'm going to put a CH2 here. Okay. This would give me this. Okay, this is going to be a triplet there. This is going to be a quartet. This is going to be a singlet with a area integration of 2, and this is going to be a singlet of area integration 3. So it's something like this. So this thing I've drawn at the bottom, whoops, is close. It's not the right thing, but it's close. Okay, I've made a guess. Okay, now what's wrong with my guess? As you can see, I'm missing a carbon. Carbon missing. All right, so I've got to put a carbon here or here. Okay, now, well, it could be either place, couldn't it? So I'm going to put it here just for fun. All right, I'm going to do that and there, and put a ketone group there. And let's have a look. And that's my new guess. So the NMR spectrum is going to be the same. This doesn't change the spectrum, this thing. But now I'm going to look at my delta values and see if that can help me. Okay, so 2.2. Let me look at the data booklet. All right, let me see if I can bring the data booklet to life. Anything down there? No. I think I can copy the data booklet and just show that, because if I can do that, you'll see what I'm talking about. So I'm going to copy all of this rubbish down to about here. What the hell? Okay, I'm going to put it here. There's the data booklet. Okay, let's sneak it down there. Okay, so which ones do I have? Let's attack this one first of all. Whoops, what are we going to call this? 1.2. Okay. Well, it's obviously an alkane CH3, so we're good with this one. This is this one. This one now is 3.5, 3.5, and it says we're looking at this one. In other words, these two. 3.5 is here, and it says a CH2 next to an O, which is exactly what we've got. So, where are we? Let me start again. The one at 1.2. All right, the one at 1.2, I'm going to guess is a CH3. Okay, that's the one at 1.2. The one at 3.5, this one, is a CH2. This is the 1.3. Delta equals 1.2 is this one. And this one is delta, what is this one? Delta 3.5 is this one. Okay, I've messed it up a bit, haven't I? It doesn't look pretty, but you know what I mean. All right, so we've done with this one and done with this one. Now, the one at 2.2 is a CH2 next to an O. So we have a CH2 next to an O, which is this bit. Okay, and the one at 4, okay, here, let's have a look over here. One at 4, well, we want this, don't we? A CH3 next to a carbonyl. Do we get that? I can't see it here, but it says, oh, sorry, yeah, it's at 4, isn't it? The one that produces the one at 4. Oh, I think I've messed this up, haven't I? The one at 4 is the CH2O. Well, sorry about that. CH2O. This one. Sorry, I think I've totally confused you all there. I think it's this one. Okay, and the one at 2.2, so that must be wrong. The one at 2.2 is a CH3 next to a carbonyl, which is this one. Okay, so this one is actually CH3 carbonyl. All right. I hope I haven't messed up too much for you, but the point I want to get across is it's often easier to have an educated guess and then see if it fits. All right. I think I personally find that easier. All right, let me stop this and go back to the question paper. Okay, this is a bit further information. When reacted with aqueous alkaline iodine, X produces yellow precipitate. That just means we have a CH3. And if you remember, we had that, and then we had CH2, and then we had that, and then CH2, and CH3. Okay, but I figured this out before, didn't I, using the NMR? But this tells us that there is this group in it. And this is the iodoform. This gives us a yellow precipitate. All right, and this is obviously the iodoform test, isn't it? All right, so I hope that makes sense, but I kind of knew the answer, didn't I? Because I worked it out beforehand. Okay, let me stop this for a second. Okay, so this is the next part. Compound W is an ester with the molecular formula of that. Proton NMR of W contains only 2 peaks. The relative areas are 9 and 1. Suggest the structure. Okay, so whenever I see a 9, I always think of this group. CH3, CH3, CH3. All right, that's 9, isn't it? Okay, and the 1, how many have we got? 1, 2, 3, 4, 5. That would give you 9 and 1. Anytime you see a 9, think of this structure. Okay, 9 protons. Okay, and there's the 1. All right, so there we go. What's that called? That's called dimethyl, 2,2-dimethyl propanoic acid. Okay, so that should be pretty easy. I'm checking the answer scheme just in case. Yeah, of course it's right. It can't be anything else, can it? All right, let me stop the video and get to the next bit. Okay, chirality. Let me pinch something from the answer booklet, or the mark scheme, I should say. There we are, and this is straight from the answers. All right, and we're going to put it in there. This is exactly what they want. I can't make this any better. All right, so this is what do we mean by chirality? There you go. Explain what was meant by chiral center. This is a carbon atom which has 4 different groups attached to it. Simple as that. All right. Suggest a structure of a V. All right. So how do I do these? Well, I've got 5 carbons. Is it carboxylic acid? I think it is, isn't it? Oh yeah, it is. It's a carboxylic acid. So there's one of those. That's there. And we have 4 carbons here. So 1, 2, 3, 4. 1, 2, 3, 4, 5. Is this chiral? No, because they're all CH2s, aren't they? Apart from the end one. So there's no chirality there. So let's pinch this one and put it here. Okay, and make that a C. Is this chiral? Well, it's not, I'm afraid, because if we're thinking of this carbon here, we've got a CH3 here and a CH3 here, so that's not chiral. So that didn't work. So let's try again. Let's put the C that I've just pinched, let's put it here. And is this chiral? Yes, it is. So let's fill it all in. This is chiral now. And you see, I didn't get it right straight away, but it's trial and error sometimes, isn't it? And there we are. Where are the 4 chiral groups? We're looking at this one. One group is a hydrogen, there's a methyl, there's an ethyl, and a carboxylic bit. All right. Anyway, guys, thanks for that. Let me stop this now and post it.